Good morning, everyone, from Seattle here. My name is Kaustubh. I am a research scientist in the audio team here in Seattle. I will be the moderator for the talk today, and I want to start by thanking all the wonderful speakers, and I want to thank all the audience for getting up early in the morning, if you are in US, or late at night if you're somewhere else. I want to thank the speakers, and I want to get straight to the questions. If you have not already asked a question and you want to ask a question, there are many channels through which you can go, and I will try to get as many of these answered as possible. So let me start with, there are some questions on the line. Let me start with the first one. This question is for you, Sriram. And the question is, it will be interesting to know if this is Beryl and MLO is already introduced in production. How was it introduced? And the complexity of rollout across many devices, limited pilots for forgiving customers, and willingness to provide feedback, and then the introduction of new versions based on the feedback. Long question, but stage is yours, Sriram.
No, that's a great question. Thanks for asking that. For us, not disrupting the user experience, that's P0. Beryl and MLO are actually both rolled out to our users, to a large majority of our users across Messenger, Instagram, WhatsApp. There's some pockets that we're still rolling out to, but vast majority of our users are getting MLO already, especially on Android. The similar story with Beryl echo cancellation. So having answered that out of the way, the second part was how did we stage the rollout, right, without disrupting the user experience. So let me answer this in two ways. We actually took a two-step approach for this. First, we built a very rigorous offline test framework to make sure that we were fully prepared before going live. So this meant building a very representative data set that's close to what our users experience. We never collect audio data from our user calls. They're all end-to-end encrypted, and we just don't collect data from our user calls. So that means we leveraged open source collections of voice data, different noise conditions, multiple languages, built up a very thorough data set that we had confidence in. Then we would test our algorithms on this, and to evaluate them, in addition to any objective metrics that we're used to, we regularly performed crowdsourced subjective evaluations throughout the development process, because this is telling us how the users actually perceive the quality, either for the codec or for the echo canceller, when they're listening to it on their own devices, in their own acoustic conditions. So this gave us a lot of confidence before getting into public testing, right? So you don't want to have too many iterations in public testing because you can't collect audio data. You work off some technical metrics, but high confidence going into the test, main reason also being not disrupting the user experience. Now that we completed all the offline tests to our satisfaction, then we started rolling out Beryl and MLO to a very small slice of our users, perform very careful A/B testing, make sure your CPU, memory, crash, all of that is under control, and then look at key engagement metrics. Once they are good, then we slowly ramp up until we roll out to the full population. So this is kind of how we staged it, building confidence offline, testing in production, and then gradually, incrementally ramping up to not disrupt user experience. And we were really, really happy to see positive engagement metric wins as we started these rollouts.
Thank you, Sriram. The next question is for you, Hong. Is it possible to dynamically switch between two modes of Beryl on the fly? Example, detecting overload on the system. Could you switch to the light mode to save CPU?
Yeah, thanks for tuning in, and that's a great question. The short answer is no, as currently the two modes that we have come with its own filter design and configuration, and we need to initialize those when the call starts. But definitely that is something that we will be looking into, as complexity does vary dynamically depending on other apps running at the same time or the battery health of the device. So definitely that is something we will be looking into.
Thanks, Hong. Jatin, the next question is for you. It's a difficult one, as this person says. You end up with RTP header, etc., taking more data than the audio itself. Is this where moving away from RTP will help the media over quick, etc.? It's a huge, interesting space.
Yeah, thanks for asking. That's a great question indeed. So you are right, like, at the lowest bit rates, we do care about the RTP header overhead itself, and it can easily add up to, like, 5 to 10 kilobits per second, depending on the packet sizes you are using. But within Meta, we are able to use some novel techniques to reduce that header overhead, even while sticking with the RTP protocol, because that has been proven to work well. But at the same time, there is, as you said, like, there is huge interest in the community, and within Meta, we have a dedicated effort to experiment with Quick and evaluate how we can get more out of Quick in all of the Meta products. Yeah, hopefully you will get to hear more about that soon, like, we launching Quick to some of the apps.
Thanks, Jatin. And there is a follow-up to that. The speaker says, I can't help but wonder how much more redundancy encoding this new audio encoder requires to ensure error concealment as effective as Opus.
Yeah, another great question. So interestingly, AMLO also has most of the salient features which Opus has, like in-band FEC is one of the very standard ones. So we added that for AMLO from the very beginning. The best part is, since AMLO is able to encode very high quality at the very low bit rates, we are in fact able to start encoding redundant audio at lower total target bit rates than even Opus. As a result, we see that we are able to recover more lossy audio in production with AMLO as compared to Opus. And the production results from our experiments kind of do share the same story. So it is possible, and on the FEC part as well, it's superior than Opus.
Thanks, Jatin. Because the next question is up for you. I'm rephrasing it a little bit. Is it worth, the reader asks, is it worth to NAC audio packets? For videos, I see a reason, but for audio, it would be good to have some more comparisons.
That's a great question. Thank you. Thanks for asking. So Jatin talked a little bit about the FEC part. We have seen that if the network is lossy, but we have much shorter round trip time, then NACs can be really effective. Also, something to note is that NACs are always higher quality than in-band FEC. So if you can use it effectively, it can provide better quality. So therefore, like, we use a combination of techniques. As you can imagine, our user base is in very diverse on different network conditions, different devices. So we use combination of these different technologies, NACs, FECs, to optimize the call quality. Thank you.
Saish, the next question is for you. Why is the central relay taking all these bandwidth estimations, temporal and simulcast decisions? Why not add these capabilities to all the relays?
That's a very interesting question. Yeah, we do bandwidth estimation at the local relays, but I think what you're talking about is bandwidth allocation, which is done only at the central relay. This is because bandwidth allocation has to take into account bandwidth estimates from all users, and it has to decide what is optimal for the entire call. Bandwidth allocation is a process by which we decide how much bit rates the user should be sending, not just how much they should be receiving. And so this has to be decided at the central relay. It is the same with temporal and simulcast decisions. Deciding whether to use simulcast and how much bitrate for those streams has to be decided centrally, because it again requires understanding of the network conditions of every user in the call. It's not that these decisions cannot be made locally. It's just that to make the decision locally, there's a lot more information that needs to pass between all the local relays, which would result in much higher chattiness of the protocol and also much higher latency.
Thanks, Saish. The next question for Yi. Is there an international group call with 10 or 15 participants? How many relays would you assign to such a call? How do you decide which relays you want to assign?
Thanks for the question. So this is a great question. As for international group calls, no matter how many participants in a call, we actually assign the user to the closest relay. So we divide the relays clusters into multiple different regions. So if the user geographically within the same region, so they will be assigned to the relay cluster, the same relay cluster. Yeah, I think that's the answer.
Thanks. Because next question about MLO for you. Are MLO and Beryl rolled out to desktop browser clients yet?
Thanks for the question. As Sriram mentioned earlier, we follow a gradual rollout process to ensure that we are delivering these new innovations with a very high quality bar. So therefore, we started the rollout on mobile platform because that's where a majority of our user base is. We will look into the other platforms in the future. Thank you.
Sriram, next question is for you. How does MLO audio codec extend to immersive or spatial audio encoding experiences?
That's a good question. As we heard in Nitin's keynote, spatial immersive and metaverse scenario is a key to our mission. That said, the innovation in MLO that we targeted was for the low bitrate segments, which is where across our family of apps for calling, we felt the strongest need was to deliver high quality audio to all our users across all geos, including the lowest bandwidth tiers. And the strongest need there to innovate and provide greater quality was in the low bitrate segments, mainly targeting speech. And doing all of this without increasing compute, like we saw in Jatin and Bikash's talk. Other than that, I will say though that MLO supports stereo, it supports multi-channel encode decode, all in a manner comparable to Opus.
Thanks, Sriram. Saish, the next question's for you. The person asks, in a multi-party call, how do you decide the central relay's geographical location? Can the central relay be eliminated eventually?
That's a great question. And that is something that we've thought about a lot. So the first part of the question is, how do we decide the location of the central relay? Now, this is a fairly complex way of determining where the central relay's location should be. This is because once a call starts, and it's very hard to relocate the central relay as the group call changes. So we have to assign the central relay fairly early into the call. And this means we have to make certain predictive decisions. We try and place a central relay closer to a hub, which is better connected network-wise. And then we cannot change it as the group call changes because it can be disruptive to the call. In terms of eliminating the central relay, we are trying to see if some of our algorithms can be made more distributed, but so far it's a fairly complex challenge. So we are for now focused on keeping it more central, but we are looking into certain algorithms. For example, audio capping is something that can be made more distributed. Hope that helps.
Give me a minute. I'm just going through the list of questions that are being added quick. Here is one for Hong. Any gotchas you would like to share when implementing Beryl AEC in real time?
Yeah, so threading issue is one of the gotchas that really stood out for us when we implement Beryl in production. It's very hard to debug threading issues. And basically what we encounter was some audio artifacts and pop and clicks. And it was due to some shared memory buffer used in our FFT routine that got accessed concurrently between both the capture and render threads. And it took us a long time to figure out, and we needed to do some audio dumping at different stages of the algorithm to really narrow down the issue. So please pay attention to threading issue.
Awesome. Following up with Jatin, what do you think is the most challenging task during MLO quality evaluation?
Yeah, thanks for asking. That's a good one. So inherently, evaluating audio quality is pretty tough. Since it's all about how the humans are perceiving it, it's really a subjective thing. Yeah. There are existing tools out there Whisker and Polka, which help you evaluate the quality in an objective manner, where you provide a reference signal and a test signal, and it can tell you a Mohs score in the range of 1 to 5. But end of the day, these tools are objective. They are trained on certain data sets, so they are not able to capture subtle differences between the audio signals. One of the main challenges we ran into was being able to reliably tell that, hey, we are able to improve the audio quality, as we are in the development process. So it would often require you to listen to some of those samples manually to make sure, like, those are actually sounding better with the improvements you are just adding as compared to before. This also makes you ear deaf to repeat listening to the same signal again and again, which makes it also harder. So that's for the development part. For the evaluation, similarly, as a very standard process in the codec development, we didn't rely on using the objective tools as the only measure. We went ahead and did the crowdsource based subjective listening test. Those were very large scale listening tests where we evaluated literally hundreds of thousands of audio files across many different listeners of different EGs and all. So the crowdsource listening tests, they are very time consuming, they are very expensive. So you can only do those so often. So you need to strike a good balance of how you're able to get most out of those while still being able to evaluate the quality fairly.
Thanks, Jatin. Next question for you, Shriram. How do you see ML algorithms for meta apps? The methods you spoke of today were mostly DSP based.
Yeah, it's an interesting question. I think I touched upon it a little bit in the talk. We at Meta obviously believe a lot in the promise of ML, and we've been leveraging that already, also for our audio algorithms. And we're taking a very judicious aspect to it, right? So ML is a very, very powerful tool, and we use it where it actually leverages, where it brings user benefits. And our main goal is to see how can we benefit the user. If we benefit a large proportion of our user base using DSP, we'll do that. If we can do that using ML, we'll also do that. So one way to look at it is on capable devices, we are already leveraging ML-based echo cancellation, for instance. The interesting thing, though, is at our scale, low-end devices are a huge proportion. So what may be a corner case is still millions of users for us, right? And from some of our experiments, even within DSP algorithms, if you are increasing complexity by, say, 10, 15, 20%, you start to see that getting reflected in engagement metrics. So we've got to be really, really judicious. So our approach is have a really good baseline solution that gives you very good quality, regardless of whatever device or network you are in, right? So even if you're on a low-end ARM v7 devices, you'd be surprised that we still have a lot of our users on those devices. We give really good quality. But at the same time, if you're on one of the high-end devices or you're on a desktop, these days high-end mobile phones are often even more powerful than some desktops. Then we also want to make use of that CPU, and there we are leveraging ML solutions. Meta is a leader in the ML space, and we have very good audio algorithms, including echo, noise suppression, etc., running using machine learned models.
Thank you very much, Sriram. Yi, the next question's up for you. In group international calls, could the network between the relays actually cause more delay and worse quality if the network itself isn't powerful enough?
Yeah, thank you for the question. I think this is very interesting. So first of all, our between the relays and the central relays, we are running inside of the FB, the Meta's backbone network. So by design, we believe in general it has more bandwidth and less packet loss compared to the public internet. The second is that we are also working on improving the Meta backbone, such as we are currently having a hop-by-hop NAC buffers between the relay and the central relays. So any packet loss, we can recover from the central relays. And also we're working on adding a quick transport between the relay and the central relay. We're hoping using the quick internal congestion control mechanism can help, will make the backbone more reliable.
Thanks. Saish, the next question is for you. If the central relay is not close enough to a participant, does that mean all these decisions like bandwidth estimation, congestion detection are also delayed?
That's a very good question. So I just want to remind you that we do in fact do bandwidth estimation and congestion control on the local relays, not at the central relay. And these decisions need to be much more real time to prevent deterioration in call quality that are coming from variable network conditions. The decisions that we do make at the central relay there's no need for them to be as real time. They need to be quick still. An example of this is like deciding if simulcast needs to be used for the call. And delaying these decisions a little bit does not have as big an impact on the call as, say, congestion control, at least in our experience. And especially, we can reduce the impact of that by being conservative with these decisions, like sending lower bitrate than what is required. The main reason we keep them on the central relay is because these need information from the entire call, not just from a single user. And so right now, we haven't figured out a way to make them distributed enough to move them to local relays.
Thanks. Jatin, the next question is up for you. While I understood that Beryl is fully implemented in software and does not leverage hardware, the person asked, correct me if I'm wrong. What is the case with MLO? There is a lot of devices with very good DSP and hardware acceleration for codecs.
Yeah, that's an excellent question. So yeah, as you rightly guessed, Beryl and MLO, they are not done in hardware. Given the time span we are operating, like, everything getting out of the door in a matter of, a couple of quarters, it's pretty much out of scope to, consider doing hardware implementations and, and then the user's latest handsets need to support those hardware implementations to be able to, fully use it. So Beryl is no doubt is fully software. Similarly, MLO. But we are able to use the neon optimizations, SIMD optimizations to squeeze out maximum out of the available CPU architectures at hand. As an example, there are also not many hardware implementations available out there for the audio codecs. EVS, which has been out there for a long time, and that is the only one which has a hardware implementation we are aware of. Opus, even it is the global standard, it still does not have a hardware implementation available out there. So you can think that it is not super common for audio codecs to have hardware implementation. Yeah.
Yeah, just to add on to it, Kaustubh, Jatin, you touched on all the important things. I think one of the things to also keep in mind here is for VoIP, it can make sense if you have the entire processing happening in hardware. You don't want to have back and forths between hardware and software, then you're kind of losing the main benefits. So if you're able to get the entire encoded bit stream from hardware, that makes sense. But we have a bunch of software processing happening anyway. And so a better way is to make use of all the SIMD optimizations that Jatin alluded to. This is where you see in the PSTN or the cellular case, codecs like AMR or EVS, they are all happening in the baseband chip because everything is happening in hardware there. If we have to also go back and forth between software, like is the case in VoIP, we prefer to do this in software with hardware acceleration, like Jatin pointed to. Echo traditionally has been a different case because, you have the audio capture happening on the chip, echo noise happening in hardware, and then you get the PCM. No more going back to hardware. But for codec, it's a slightly different use case.
Thanks, Sriram and Jatin, for that response. We'll do 2 rapid-fire questions before we run out of time. For Saish, do the relays transcode the stream before relaying it or pass it through?
Good question. So we don't do any kind of transcoding on the relay. In fact, on WhatsApp, all calls are end-to-end encrypted, which means we have no access to the contents of the packet to like decode or re-encode them. So there's no transcoding at all on the relay. Even when it's possible, we like to keep our infrastructure uniform so that they have the same capabilities. So we don't plan to do any transcoding on the relay.
And the last question, this is for Yi. What's the main benefit to run mix of send, receive BWE on the relay compared to just using TWCC on send side?
This is a good question. I think for the send side, we know the benefits. It can help the client to understand their uplink, and for the relay to understand the downlink. The receive side is more on the relay side to determine what's the received bitrate. So we're using a remote bitrate estimator to estimate the bitrate for the uplink, which is from the client to the relay. Then we can using this information to fit into our bandwidth allocator in the central relay. Then we're using those information to help make the better decisions on the central relay for the bandwidth allocation, such as simulcast, sample layer, all based on those bandwidth allocation results.
Thank you very much. And I would like to thank all our speakers, Shriram, Huang, Jatin, Bikash, Yi, Saish, not only for your wonderful talks, but taking the time to answer these questions. Thank you very much to all the audiences and hope you have a wonderful RTC at Scale 2024.